Welcome to Installation of Large Format Wall Tile, Challenges and Solutions, presented by TEC. Completion of this course qualifies students for one AIA CES learning unit. To earn credit at the conclusion of the course, you must take a 10-question quiz. Scores of 80% or higher receive credit. You may take the course and quiz as many times as necessary to pass. H.B. Fuller, manufacturer of TEC brand products, is a registered provider with the American Institute of Architects Continuing Education Systems. Credit earned upon completion of this program will be reported to AIA CES for AIA members. Certificates of completion for both AIA members and non-AIA members are available upon request. This program is registered with AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material of construction or any method of handling, using, distributing, or dealing in any material or product. Questions related to specific materials, methods, and services should be directed to TEC at the conclusion of this presentation. This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without written permission of H.B. Fuller is prohibited. By the end of this course, you will be able to 1. Identify the benefits and potential challenges of using large format materials. 2. Assess project environments and select the most appropriate large format tile or stone, mortars, and methods for a successful installation. 3. Explain how new technologies have enhanced mortars and mastics, and compare and contrast the uses of these adhesives. And 4. Utilize solutions for installing large format tile that avoid common installation pitfalls, including discoloration and lippage. As the manufacture and use of larger and larger tile becomes increasingly more common, it is critical to understand the unique requirements for installing large format tile on walls and floors. Technology has allowed for larger and larger tile, and industry standards have evolved as tile size has increased. There are general size parameters that comprise the large tile and large format tile categories. These parameters are distinguished by material type, including ceramic tile, natural stone tile, natural stone panels, and thin porcelain panels. Historically, ceramic tile larger than 8 inches by 8 inches have been considered large tile. When used in wall installations, large tile are most often at least 12 inches. Large format tile, however, has been defined as tile that have at least one side exceeding 15 inches. On average, large format ceramic tile used on floors are 16 inches by 16 inches. Similarly, natural stone tile is available in sizes ranging from 12 inches by 12 inches to 24 inches by 24 inches. When less than 3/4 of an inch thick, natural stone tile must be adhesively attached for installation. Natural stone panels are both thicker and larger than natural stone and ceramic tile. Their thickness ranges from 3/4 of an inch to 2 inches. Unlike natural stone and ceramic tile, they are typically rectangular and range from 4 feet to 7 feet long and 2 feet to 4 feet wide. Natural stone panels must be mechanically attached when used in vertical applications. Large, thin porcelain panels range from only 1/8 of an inch to 9/32 of an inch thick and can span up to 10 feet long and 5 feet wide. These panels can be used to cover large areas but are significantly lighter than other large format tiles. They are adhesively attached. Despite some installation challenges associated with it, large format tile has become a popular option for floor and wall installations because of transitions in both supply and demand. Consumers and designers increasingly demand the aesthetic benefits that large format tile provides. Whether used in floors or walls, large format tile makes spaces appear larger and more open, and provide a neater, more modern appearance. At the same time, technological advances have allowed manufacturers to produce larger and larger tile in thinner and thinner sheets. With the technology in place, designers are turning to large format tile, and now also large thin panels, not only for their aesthetics, but also for their better long-term performance that results from fewer joint lines, material and construction efficiency, and easier lifetime maintenance. Meanwhile, global reductions in the cost of natural stone have created an even higher market demand, making this the ideal time for designing with and specifying large format tile. Research used in the development of this course is provided by the Tile Council of North America 2013 Handbook, the American National Standards Specifications for the Installation of Tile, the Marble Institute of America Dimension Stone Design Manual, version 7.2, the Tile Contractors Association of America, the International Masonry Institute, the National Tile Contractors Association Reference Manual, governmental building codes, and by information provided by industry manufacturers. In the first part of this course, we will address potential installation challenges that are unique to large format tile, before moving on to common aesthetic issues and diving into real-world case studies. Large tile installations magnify issues associated with traditional tile installations. Why? In most cases, they are thicker and heavier, and therefore harder to handle than standard size tile. In the case of thin large format tile, which can be as long as 10 feet, it may take up to 3 people to install one panel. They require tighter installation tolerances and are more expensive to both purchase and repair. To avoid costly issues down the road, you must take appropriate precautions when working with large format tile. Given the higher potential for installation challenges, it's very important to take into account a project's environment when choosing tile or stone type to ensure that your installation performs as expected and has a long service life. For example, certain large format materials are intended only for use in dry environments, while others can be used in wet environments and exterior applications. You must also plan your installation methods and materials to meet the specific challenges of both your project environment and of large format tile. There are large format options for a variety of interior project environments. Dry areas are the easiest to specify, as generally all types of tile are suitable for use where moisture is not an issue. In contrast, wet areas require a low moisture absorption tile. Exterior installations necessitate durable, easily maintained tile with low porosity. Exterior tile installations must be able to withstand extremes in weather, including continual freezing and thawing cycles in some areas of the country. Using large format tile in commercial environments can provide considerable advantages over other types of tile. Commercial environments frequently experience high volumes of foot traffic. For that reason, lower maintenance tile are often specified for commercial interiors as well as exteriors. One way to reduce maintenance is to specify tile with lower porosity. Low porosity tile requires less maintenance, is easier to clean, and wears better than higher porosity tile because its density does not require sealing. Note, however, that special consideration is required when large format tile are used with installations that include drains. It may be possible to accommodate drainage depending on the type and size of drain, but you must take care to use the appropriate drain tile combination. If a drain is necessary in a large format tile installation, linear drains can be specified to accommodate water runoff. Shower bases can be sloped on a single plane to a linear drain, allowing for the use of large format tile. If your installation requires a circular drain, however, the drain may be surrounded by smaller tile before transitioning to large format tile. The American Society for Testing and Materials Water Absorption Test, ASTM C373, allows for the classification of tile and stone according to what percentage of its weight it absorbs in water. These classifications are useful when specifying materials for various environments. Ceramic tile with an absorption level of 0.5% or less is deemed impervious. A vitreous ranking denotes absorption levels between 0.5% and 3%. Semi-vitreous tile have absorption levels between 3% and 7%, and tile with absorption levels of more than 7% are deemed non-vitreous. ASTM C97 is used to classify the absorption levels of stone materials such as granite and limestone, commonly used in making stone tile and panels. Granite's typical absorption levels range from 0.02% to 4%, or from very impervious to semi-impervious, whereas limestone's levels are between 0.6% and 29%, from vitreous to non-vitreous. Special sealers are often applied to tile materials to decrease their absorption levels. The Tile Council of North America's Handbook for Ceramic Tile Installation outlines best practices of tile installation, including drawing, recommended uses, limitations, requirements, materials needed, preparation methods by other trades, preparation methods by the tile trade, movement joint, and installation specifications. Before installation begins, you must carefully consider substrate variation, which is especially critical when using large format tile. For tile up to 15 inches, the maximum substrate variation is 1/4 of an inch in 10 feet and 1/16 of an inch in 1 foot. For large format tile, that is anything over 15 inches on any one side, the allowable variation decreases to just 1/8 of an inch in 10 feet and 1/16 of an inch in 2 feet. In other words, the larger the tile, the more critical the variation in the plane of the substrate. Minimizing substrate variation is absolutely essential to long-term performance of large format tile installations. Variation in substrate beyond established tolerances can cause problems when trying to install a flat floor, and can even create tripping hazards. Moreover, substrates must be adequately prepared and leveled if necessary. Where variations are minor, the use of a medium bed mortar can ensure proper bonding. You can minimize the problems caused by substrate variation in walls by patching or skim coat. For floors, self-leveling underlayments provide another option for reducing substrate variation. Concrete is a very common substrate, but does require that proper precautions are taken. Concrete often shifts, shrinks, and cracks, and that can affect materials installed over it. When tile is bonded to concrete, cracks occurring in the concrete can in turn cause cracks in the tile installation. However, the following statistics should help to ease concerns about installing tile over concrete, or at least help you take proper precautions. It's important to know that half of the total shrinkage of concrete occurs within the first 60 days after it is poured, and the majority of shrinkage occurs in the first 3 to 6 months. In most cases, new shrinkage cracks will not develop in concrete older than 3 years. Products made specifically for crack isolation can protect tile from shrinkage cracks, as well as protect an entire floor from being affected by cracking in the concrete. Crack isolation membranes form a uniform surface over substrates and can be used in residential and commercial applications, on interiors and exteriors. Installing tile over a crack isolation membrane using a thin-set method is a relatively easy way to help ensure tile's long-term performance and aesthetic. In thin-set installations, a crack isolation membrane is bonded to the concrete. Then tile is bonded with modified thin-set to the surface of the crack isolation membrane. Moreover, there are a variety of crack isolation products available. They include sheeting materials, liquids, and trowel-applied membranes. In sheet applications, the sheeting material, such as polyvinyl, polyethylene, or butyl, is placed atop a layer of mortar or adhered directly to the substrate via a peel and stick adhesive. Another layer of mortar is needed to set the tile. Trowel-applied membranes are applied to the substrate with a V-notch trowel, smoothed, allowed to dry, and then topped with the mortar to set the tile. Membranes can also be applied with an airless sprayer or nap roller. Some specialty products can be used both as a mortar and a crack isolation membrane, depending on how they are applied. When not using one of these systems, it is important to check that the mortar you use is appropriate for the crack isolation product you specify. Industry standards for proper coverage apply to large format tile. Coverage refers to the contact area of the bonding material to both the tile and the substrate. Average coverage for tile should be at least 80% generally, and increases to 95% in exterior, shower, or wet area installations. Natural stone, however, requires a coverage area of 100%. Proper trowel selection and troweling techniques aid in meeting these requirements. You can see in these examples that 100% coverage of the substrate in the natural stone installation can be achieved by using a method known as backbuttering. This method involves applying mortar to both the backside of the tile and directly onto the wall or floor itself. This facilitates fresh material contact for better bond and helps to fully embed the mortar into the tile for 100% coverage. The contractor responsible for this installation did not achieve 100% substrate coverage. You can clearly see gaps in coverage in this photo, which is a result of an installation technique known as the dot method. This method relies on applying dots of mortar to the backside of the tile only, which does not allow for full substrate contact or proper embedding, and can leave unsightly circular stains, efflorescence, and color variation beneath installed tile, as you can see here. The dot method decreases the strength of the bond, and the voids in coverage leave tile susceptible to moisture trapping, which can result in unsanitary conditions, including the buildup of bacteria and mold behind tile. In freeze-thaw conditions, trapped water can freeze and expand, causing tile to pop off the walls. With the tile removed from this facade, you can see that adhesive was applied using the dot method, an error that has resulted in the complete removal and reinstallation of tile. To avoid costly repairs and renovations, it is important to achieve 100% coverage during initial installation. Again, substrate variation, bonding material, trowel selection, and troweling technique are all critical factors to consider to achieve proper coverage. Resin-backed stone minimizes breaking of thin-cut, fragile stone, but it can present real challenges to installers. Increases in stone cutting technology has allowed for the production of thinner and more fragile stone tile. To maintain the structural integrity of stone tile, many manufacturers back the stone with a substance that adds rigidity and stability. These backings are typically epoxy and can be smooth or have a texture created with an aggregate broadcast into the resin. Stone tile backed with resin will typically have a mesh backing with a shiny coating. Despite their benefits, these backings are difficult to bond to. Consult with the manufacturer of your setting material for recommendations to ensure successful installation. If you observe this, remember to refer to setting material manufacturers for installation recommendations to minimize bond issues. When selecting the materials you will use to install large format tile, you must ensure that they meet or exceed installation method requirements. ANSI standards and manufacturers' performance requirements for proprietary systems can guide you through the selection process. The most important product performance requirement when installing large format tile on walls is good bond strength with non-sag capabilities to avoid tile slippage or falling during installation. Medium bed characteristics are also important to control any shrinking that may occur during the curing process if a thick mortar application is needed for coverage. For floors, it is equally critical to look for materials with good bond strength and medium bed characteristics to both control shrinking and to prevent heavy tile from slumping into the mortar bed. To install large, thin panels on walls or floors, you must be careful to select materials that are appropriate for their installation. While good bond strength, non-sag capabilities, and medium bed characteristics remain critical to a successful installation, It is also important to use materials with high resistance to shock and impact that have adequate compressive strength to support the panels. Tile mastic is a ready-to-use organic adhesive option for tile installations. It is considered easier to use than mortar because it is easy to trowel. However, it typically requires at least 24 hours to set before grouting, and setting time increases when it is used with larger and less absorptive tile. This is because mastics are pre-mixed materials that do not contain cement. Mastics also have drying issues with large porcelain tile. Mastics may have size limitations and are suitable only for interior installations without waterproof membranes. ANSI classifies two types of mastics. According to ANSI A136.1, Type 1 mastics may be used in commercial wall and ceiling applications in dry and limited water exposure settings, or in residential wall and ceiling applications in any setting, including wet exposures. Whereas Type 2 mastics may only be used in residential wall and ceiling applications in dry settings or those with limited water exposure. Earlier, we discussed how advances in technology have allowed for larger tile. Similarly, advances in mortar and mastic technologies have aided in the installation of these larger tile. Traditionally, mortars and mastics have been best suited for smaller, lighter tile and stone. Heavier, large-format tile and stone would have sagged or slumped during installation. Now, new thin-set mortar and mastic technologies have sag and slump resistance when used with tile and stone as large as 20 inches by 20 inches, weighing up to 7 pounds per square foot. Although both mastics and mortar have evolved with new technology, certain situations call for mortar rather than mastics. ANSI offers 4 performance classifications for Portland cement mortars: A118.1, A118.4, A118.11, and the newly established A118.15. With these 4 performance classifications, the tile and stone industry now has separate and distinct performance specifications. Used in conjunction with the ISO 13007 performance standard, architects and installers can now select the level of performance that meet the specific application requirements. A bond shear testing apparatus is used to measure the bond strength of the mortar to various tile materials. Mortar, as opposed to mastic, is required for commercial construction in wet areas for use on exterior installations. It is also used to ensure bonding to waterproof and anti-fracture membranes per membrane manufacturer's specifications. Technological advances have improved the composition of mortar. The introduction of lightweight fillers, known as microspheres, has lowered the density of some mortars, while allowing them to maintain a compressive strength of up to 3,000 psi. This composition enhances interaction with cement and offers greater coverage per pound, while its lighter weight enhances non-sag wall performance. Moreover, the smooth, non-porous microspheres in mortar roll over each other when they are troweled, producing a ball bearing-like effect that improves their workability and reduces tile setter fatigue. In this image, you can observe how the microscopic spheres intermix with the mortar material. This effect achieves a lightweight product without compromising strength. Advancements in nanotechnology, which is the manipulation of matter on an atomic level, has led to increasingly innovative mortar technologies. Nanotechnology has allowed for a more in-depth analysis of the materials being used in mortar. By studying adhesion in nanometers, or billionth of meters, that is, units the size of 1/10,000th the width of a human hair, materials can be developed at these molecular sizes to improve non-sag and non-slump performance for large-format tile and stone, wall, and floor installations. This photo shows mortar that has been chemically fused to the substrate on the left side of this picture. Nanotechnology has allowed for more surface-to-surface connection, and thus a tighter bond between mortar and substrate. The first part of this presentation explained how changes in technology address the challenges that large-format tile and stone present to installers. Now we will discuss aesthetic issues that may arise after installation. Many designers and customers opt for large-format tile and stone because they value the aesthetic it brings to a space. However, without proper installation and maintenance, This aesthetic may be difficult to sustain. Lippage occurs when stone or tile are not laid to a uniform level, so that one edge or corner of a tile is higher than the edges or corners of its adjacent tile. This results in an uneven appearance, which can be significantly worsened by lighting conditions, and can also create a tripping hazard on floor applications. Some lippage is normal, in most cases inevitable, but lighting can make lippage appear worse than it really is. According to the TCNA, the improper location of interior light fixtures may produce shadows or undesirable effects that exaggerate lippage. Light shining on exterior installations at a flat angle, almost parallel to the surface, similarly can accentuate normal and acceptable inconsistencies. The NTCA reference manual also offers guidance on preventing and minimizing lippage and its relative appearance. The chief culprit for lippage is an irregular substrate. Earlier, we discussed the maximum variation in substrates in various size tile. Acceptable tolerance in substrate variation becomes increasingly tighter as tile sizes get larger. Variation in a substrate is measured using a 10-foot straight edge and a level. Where variation in a substrate exceeds these tolerances, you can use patching and skim coat materials to address the problem. In flooring applications, a self-leveling underlayment, or SLU, can be used to smooth and level the subfloor. The use of SLUs has become an increasingly common method of providing a flatter substrate. Avoid trying to compensate for irregular substrates with mortar or mastic, as this strategy generally results in improper tile-to-substrate coverage. Here we see lippage resulting from variation in substrate that surpasses maximum variation tolerances. The lighting conditions accentuate the lippage in this installation. In this photo, you can see that one tile is more than 1.75 millimeters. That's 0.069 inches, or the height of a quarter, higher than the tile adjacent to it. The ANSI and TCNA handbooks list allowable lippage for various tile sizes. Lippage also occurs frequently in ungauged stone. Ungauged natural cleft slates are increasingly more popular for both residential and commercial applications. Their varied patterning and textures gives them a unique and often beautiful appearance, but also present installation challenges. Ungauged stone typically has more variation in thickness than comparable gauged stone, which increases the likelihood of lippage. To compensate for variation in thickness, ungauged stone should be installed in a thick or medium bed mortar. You should always grout ungauged stone to provide required support and avoid lippage where tile meet. Wider grout joints, those between 1/4 inch and 3/8 of an inch, typically provide enough room to compensate for thickness variation. Grout joint width can help address another cause of lippage, warping. Some stone types, including green marble, white onyx, and jade, are especially sensitive to moisture and more apt to warp. 100% epoxy mortar is required to install moisture-sensitive stones because water mixed with other types of mortars may cause them to stain or warp. Some warpage of tile is natural and inevitable. In fact, all tile are somewhat warped because shrinkage occurs during the tile firing process. However, moisture-sensitive stones require a 100% epoxy mortar to avoid post-installation warping. Larger tile are more prone to bowing than their smaller counterparts. This means that the center of the tile or panel is often slightly higher than its ends. Because of this, you must give special consideration to running bond, or brick patterns, when using large format tile. As stated in ANSI A 108.02 4.3.8.2, if the side of the tile being offset is greater than 18%, the running bond offset should be a maximum of 33% unless otherwise specified by the tile manufacturer. Offsetting the tile to this specification reduces bowing by aligning parts of the tile that are of similar heights. Because some stone is porous, it stains very easily. Its pores absorb materials like a sponge. Taking special precautions to avoid installation pitfalls will help prevent staining. Earlier, we discussed the importance of achieving 100% coverage when installing stone tile. Doing so will help to avoid unsightly staining and discoloration, while achieving proper adhesion. For this and other reasons, it bears repeating that the dot method should never be used to apply adhesives in stone installations. You cannot achieve proper coverage or avoid staining if you use the dot method. If you are using a notched trowel to apply mortar, you must be sure to flatten the ridges it forms to achieve proper coverage. Employing the back buttering installation method will also ensure proper coverage. Improper, uneven coverage can lead to a discolored appearance and inadequate bond. You should always use mortar, not mastic, for stone installations to avoid mastic bleed-through. When applied to stone, mastic can bleed both into the grout and through the stone, which causes staining and discoloration. Tile contamination from grout applications can also negatively affect tile appearance. This can occur when the installer leaves a grout residue on the tile during the grouting process, causing a hazy appearance or, even more, dramatically discoloring it. Tile contamination is especially common in very porous or unglazed tile and slate. Porous and unglazed tile and slate have a surface that grout attaches to very easily. Grout release agents can be used to address the problems associated with grout haze contamination. They are clear liquids that block the grout from bonding with the top surface of unglazed tile or slate. You should wipe or brush the grout release agent onto the tile after it is installed, following the manufacturer's recommendations. The coating temporarily seals the tile surface to help prevent grout haze and discoloration. Now that we've discussed the basic parameters of installing large format tile and outlined how you can achieve your desired aesthetic, it's time to ensure that your tile and stone installations perform the way you want them to. Let's explore a couple real-world case studies where large format tile was installed successfully. The Fashion Mall at Keystone in Indianapolis, Indiana, recently underwent a 150,000 square foot expansion and renovation. This project aimed to modernize the existing structure, as well as provide room for new stores and a new food court. Large format tile was used to add a modern aesthetic to the expanded and renovated space. Santa Rosa Mosaic and Tile Company, Incorporated, served as tile contractor and installer. They installed large format tile in the mall's concourse, food court, and restrooms. The concourse now features large format tile that are 12 by 24 inches in its border and 24 by 24 inch tile in its interior. The tile installations in this space contribute to its visual interest. Large-scale patterns use 3 colors of tile that are different from the field tile, while the food court features 6 tile colors and 3 tile sizes for a contemporary look. Large format tile provided for modern design possibilities in this space. The Keystone project presented its installers a particular challenge. The entire installation had to be completed without interrupting regular business. This meant that the installer had to have the tile laid, mortar set, and grout applied in just 10 hours while the mall was closed. Because of this strict time constraint, the installer relied on fast-setting mortar made specifically for large format tile. It provided non-sag, non-slump characteristics and exceeded ANSI A118.4 and A118.11 shear bond specifications. They used a grout to provide the high stain resistance critical for commercial environments. The grout also had fast setting capabilities and provided color consistency, efflorescence resistance, crack and shrink resistance, and mold and mildew resistance. It exceeded ANSI A118.7 specifications. This project illustrates that if proper guidelines are followed, large format tile can be installed quickly and efficiently to create a beautiful end result. Coba Casino Restaurant, located in Lexington, Kentucky, relies on large format tile to achieve a very specific aesthetic. The restaurant contains more than 60,000 square feet of glass, porcelain, and ceramic interior and exterior tile in a design inspired by cenotes. Cenotes are natural underwater sinkholes, found most often in the Yucatan Peninsula. Tile, including large format tile, helped the designer achieve that look. Large format tile was used both in the interior and the exterior of the installation. 12-inch by 24-inch solid porcelain tile gave the exterior of the restaurant a travertine look. Because the large format tile was used in an exterior application, it was installed with mortar rather than mastic. Moreover, to ensure a successful exterior installation, the installer had to achieve 95% coverage. Following the specifications for large format exterior tile helped these installers achieve their client's desired look. With constantly improving technological advancements and a global increase of material supply, it is clear that the popularity of large format tiles and large thin panels is ever growing among architects and designers. If you take care to understand and prepare for all installation and design challenges associated with these panels, you can create beautiful spaces that last. Proper material selection is critical to the success of any project, especially when it comes to specifying for different environments, including interior, exterior, commercial, residential, wet or dry spaces. Selecting the correct installation products and knowing how to effectively use them is equally important to material selection in order to avoid common mistakes that can leave a project looking badly, or worse, compromise its performance. This concludes the AIA CES Learning Unit. If you have any questions related to the contents of this course, you are welcome to contact a TEC representative at your convenience. To earn credit for this course, you should now take a 10-question quiz. Scores of 80% or higher receive credit. But remember, you may take the course and quiz as many times as necessary to pass.